mail all over the place. Today, we are going to be introducing ourselves to another kind of oscillatory motion.
Looking good.
A pendulum, as we talked about the other day, goes back and forth, repeats itself. You ever heard of an oscillating fan?
Yeah, I have.
What's an oscillating fan do?
No.
Turns back and forth and blows in different directions.
I know what
That's
you're
what
talking about.
oscillates do. Yes.
That's an oscillating fan?
Oh, get
Oscillating, yeah, they call it oscillating. Oscillating just means going back and forth. Like a sine function is an oscillator. Another way to talk about pendula, there's something called, if you ever hear the fancy term for a pendulum or that type of motion is simple harmonic motion. But what we're going to be talking about today is a different sort of oscillating, a different sort of back and forth, a different sort of repetitive motion, and that is the motion of a thing going around in circles. And so in class, as we work through the examples, I should probably wrap it up on my finger so that it's a little less likely to fly off into your face.
Well, it's a helicopter that you
We had,
do well.
in Chem 2, we had to draw him doing that and hitting you in the face.
So we have, yeah, that's going to happen in a little bit. All right.
Always prepared. And it was you.
Put on your goggles.
Oh, it was me?
Yeah.
Yeah, it was specifically you.
On your paper, I drew a little bubble and put Newton's first law and made an exclamation mark.
So if you have a thing going around in circles, there are a few characteristics that we can measure of the circle. What are you doing? Why are you holding that weird? It's not like an iPhone. You hold it regular, and it's going to take a nice. It's a camera, man. It's a camera. It's not an iPhone. Henrik's fault. Henrik's terrible at this.
My bad.
So if we, I'm going to put this on the internet, people. All right. So this is one example. Anything going around in circles. It could be a car racing around a track. Anything going in circles, or or planets going around the sun. Anything going in circles like this in a repetitive way. So, what are some of the characteristics of this circular motion? Well, one is the radius, of course. There's a radius. This is a circle. There's a radius here. So, there's a radius.
There's a diameter.
There's also a diameter, but who cares?
Apparently no one cares about that.
No one cares about the diameter. That's exactly right. There's also, just like with the pendulum, there's a...
Gravity.
Oh. Stupid marker got in the way. Ow!
Oh!
Back hurts. There is gravity, of course. What we're going to find here, though, is that gravity is not going to, well, it depends on what you're talking about. For this situation right here, gravity is pulling it down, but what we'll find by the time we're done is that the other forces on it are much larger than gravity, and so we don't really need to worry about gravity right now. And so, so let's, so you got your radius of the thing, and you've got of course, your period of the thing, and of course 1 over the period would be the frequency, so you can talk about frequency or you can talk about period, but you don't really need to talk about both. So one of the things I want to, and there's also this thing, as it's going around in circles, it has a velocity, doesn't it? It has a velocity, and velocity is defined as what?
Speed
and direction. Exactly. Velocity is speed plus direction. If your direction changes, your velocity changes. So does this thing have a change in velocity right now as I spin it? Is its velocity changing?
No.
Yes.
Why? Yes.
Because of
Why?
the direction.
The direction's constantly changing, right? The speed may not be changing, but the velocity is, because it's changing directions all the time. So that means that the thing must also be accelerating. Radius, period, frequency, velocity, acceleration. So these are the parts of the system that we're going to have to look at, and I think that we'll do that on the smart board, so you can pause that.